Hi, another review today. I recently decided that I needed another bench power supply for various reasons. I've got a couple that I use sort of all the time. This bottom one's a Farnell LS3010, which is probably about 20 years old, but I use it all the time. It's a great piece of kit. And there's a Xantrex, which is for high power stuff, that goes up to 150 volts at 7 amps. The problem is whenever I need to use a power supply away from the bench, it's a pain in the arse sort of taking these off the bench, taking everything to bits. It ends up as a bit of a mess. So I decided I was going to look for a sort of sensible price general purpose power supply. Now I knew pretty much what I was looking for spec wise. Has to go to 30 volts because I'm quite often dealing with 24 volt stuff, and 30 volts is a good sort of spec for a general purpose bench power supply. If you don't really know what sort of stuff you're going to be working on, 30 volts is a fairly sensible value. I wouldn't really advise going for something that'll only go to maybe 15, because sod's law is, you're going to need something a bit higher at some point in the future. Current wise, probably about 2 amps, so just really general purpose power supply. I wanted it switch mode rather than linear because I wanted it fairly small and light, and I also wanted it to be in a vertical format so it didn't take up too much bench space. So I had a quick look around, see what was available. It's a long time since I've looked at that sort of stuff. I found this. This is a Tenma 728345. The price on this varies a lot. The cheapest I found was CPC, which is 86 quid including VAT. The prices vary a little bit. Farnell do it a bit more expensive, and there's some joker on eBay flogging these for 160 quid. There's 3 versions of this model. This is the mid-range. This is 3 amps, 36 volts. There's also a 5 amp, 20 volt and a 1.6 amp 60 volt one, but this mid-range one is about right for what I was looking for. Right, start at the back with a not very interesting bit. You've got a standard IEC mains inlet, fuse holder there, mains power switch. Switches on the back aren't brilliant, but at least this is on the top so you can reach over and get it easily. You're not sort of reaching around there, so that's probably an acceptable compromise. Vents on the side and the bottom for airflow through it. On the back there's also this tab. I think, looking at the size of it, this is intended for a security tie down rather than a ground. There's a little bit of plastic over it. You do sometimes get extra ground terminals on the back, mainly for countries that have a sort of slightly tenuous grip on the concept of earth mains outlets, so they can actually put a separate safety earth. But looking at the size of that, I think the idea is that's a sort of padlock type thing. And there's this handle on the top. I think it's a bit of a waste of time. I mean, you can just pick it up like this. I think if anything that gets in the way, because it means it's less easy to stack things on top of it. So I think that handle's probably going to get unscrewed and left off. It's not really that useful as a handle, I don't think. And on the front you've got the basic controls you'd expect. The one thing I don't like is it's got 4mm sockets. It doesn't have binding posts, which I think on a power supply you're always going to sometimes want to just connect some random piece of wire onto it without having to find a lead. But what I've just done is I've made up a little adapter using some 4mm plugs and some PCB. I might look at actually see if I can swap these. The problem is because these are sockets for shrouded 4mm sockets, the holes behind there are going to be quite big, so what I might end up having to do is actually put a bit of PCB in there to have some smaller holes for screw terminals. But for the moment that's a reasonable compromise, and the location of the sockets means that it doesn't actually stick out very far. You've got the positive and negative, and you've also got a chassis ground output. I don't particularly like that layout. I'd sooner have the positive and negative next to each other, because you can get various ready-made dual plug leads which have a standard 3/4 inch spacing, and you'd normally want those between plus and minus. I mean, the extra ground terminal on there is not especially so. There are occasions where you actually want to link negative to ground, but I'm not really sure having that terminal there is particularly useful. You've got an output on-off. This is a momentary on-off button rather than a sort of a mechanical latch button. One advantage of that is that whenever you turn the mains on, it'll always come on with the output off, so you don't accidentally turn it on and stick too many volts down something, because last time you used it, it was set to a high voltage, and you've got voltage and current adjust. These feel like encoders. The knobs stick out quite a long way, and if you're sort of on a bench situation it's not a problem, but if you're sort of taking this around like this, might be a little bit vulnerable to getting damaged. If we turn it on, the display contrast is probably a little bit better in real life than it looks like on the camera. The contrast is very good. The viewing angle is pretty much any way you can physically see it, you can view it, so that the contrast is excellent. You've got 4 digits voltage and current display. There's a little bit of jitter on there. You generally get 1 or 2 digits sort of floating around. And the other indications, you've got the output on-off indicator, which you can probably just about see is like a little switch symbol. Now, what I don't like about that is, you know, they've done this custom LCD. I'd much rather see a much more bold indication, like a big block that comes on and off, so you can instantly see at a glance whether it's on or off. Failing, you know, ideally I'd like a LED on there, but with custom LCD, I think it's a bit of a shame they've only just used this tiny little bit of logo here. The other indications, you've got CV and CC for constant voltage, constant current. The encoder action is quite slow. I mean, higher end power supplies tend to use multi-turn pots, but I suppose it's better to have it a bit too slow than too fast. So yeah, to wind it all the way down takes a good few turns, certainly more turns than it would on a 10-turn pot. It's maybe perhaps 20 turns for the full range, but it means you do get reasonable adjustment. One thing I don't like is this display update is too slow. I'd like that at least twice as fast as that, especially when I'm adjusting. But we'll have a look to see if there's anything we can do about that. But let's look at this as it stands for the moment. The other thing which I don't particularly like, I don't know how common it is on lower end power supplies, is that when the output's off, the current meter just reads 0. Now, this display is effectively no use when the output's off. So what I'd have preferred to have seen, which a lot of other power supplies do, is that when it's off it should actually show the set current, the actual current limit, and when it's on it shows the actual current. So for example, this Farnell one does that, so the output's off and it's showing the what you set the current limit to, then when you turn it on it then shows what the actual current is. I'm wondering if maybe the reason they've done that is there's some non-linearity or something in their current control circuitry, so that if it may not be able to provide an accurate set point. So yeah, the way they recommend you set it is you just short the output and set the current. If you just short the output, turn the output on, it will then show you the actual current that's flowing, so you can then set the current that way. Which it depends really how often you're using this in constant current mode as opposed to just using it as a current limit. So it's a minor annoyance, but it's livable with, I suppose. Well, I've measured the accuracy of the meter against an accurate meter, and it's fine. I mean, it's well within the sort of figure you'd expect. So what I'm going to have a quick look at though is the output noise, and also any transient, if it's got any transient issues. This is an example of where measuring things like noise, this is one of those locations where you really can't use the ground lead on the scope. Let's show you what I mean. If I just connect that using the ground lead, you can see this is just the monitor connected to my scope, so I can actually show both next to each other. That's looking fairly noisy. There's quite a lot of sort of spiky noise on there. That sort of baseline noise is about sort of 50 millivolts with peaks about double that. The proper way to measure stuff like this is to actually get rid of the ground lead. Different probes have different ways of doing this. Some just have a ground point on the end, but you actually need to get a very, very solid ground. So this is actually now connecting it directly, and we see those higher spikes are just completely gone, because those were just artifacts caused by the inductance of the ground lead. So what we're seeing here is something of the order of 30 millivolts, which is about what the daily sheet specs, which I think is perfectly acceptable for a switch mode bench power supply. You know, if you're doing super low noise stuff, then go buy a big heavy linear supply, but for the majority of applications I think that's fine. Let's just see what happens when we give it some load. This is a 12 ohm resistor, so let's just connect that across it and see if the noise changes significantly. No, I mean, it's supplying an amp and there's just no obvious increase in noise, so I think that's perfectly adequate for a sort of a fairly cheap switch mode supply. I think that's pretty good. One quite important consideration for a bench supply, and something where some of the cheap ones fall down quite badly, is you need to make sure they don't overshoot to produce any spikes, both when you turn it on and also when there's a sudden change in load. So I've set this to 12 volts, I've put a nominal 10k resistor across it because there is a little bit of capacitance across the output, so if you turn it off it takes quite a while to drop down. So I'll just turn it on, bang, that looks fine, there's no overshoot at all. We'll try a different voltage, just try setting it to so it's 25 volts, turn that on, again fine, no overshoot whatsoever, quite happy with that. Let's try under a bit of load. I've got my 12 ohm resistor again. Right, so this is turning on 25 volts with 12 ohms across it, so that's 2 amps supply. Turn it on again, very small little overshoot there, but I'm not too concerned about that. Straight at 12 volts. 12 volts again, small amount, but I wouldn't really be too concerned about that. I'll just check what it's like at lower voltages. Set that to 1 volt per div. I'm going to set this down to say 3.3, which is obviously going to be a quite commonly used voltage. Again, this is still with a 12 ohms across, so that's going to pull about 250 milliamps. So turn that on, set the trigger level. Not quite so good. I mean, we've got about a 1 volt overshoot on that. Not brilliant, but probably not totally fatal. Just try it without the load. That's with a light load, that's just with a 10k on 3.3 volts, there's no overshoot at all, so it looks like it can sometimes overshoot a bit if it's got a fairly high load at startup. Let's just look at load transients. This is at 3.3 volts with no load. Again, I'll connect the 12 ohm resistor, and I'm not seeing really anything at all voltage wise. Let's crank it up to the full voltage. Right, that's 25 volts. So a 2 amp load. Again, a tiny dip, but nothing. And when it comes off again, there's a very small glitch, but I think that's perfectly acceptable. I have noticed it very occasionally at certain loads being slightly unstable when you turn it on. This is 4.7 ohm load at 5 volts, so it's about an amp. But sometimes it goes into this mode and you can actually hear it making a slight buzzing noise, but when you disconnect the load it seems to recover. So that's not brilliant, but I've only seen it do that one sort of load combination, and say at least you do know about it because you can hear it. Right, so a quick look inside. I'm not calling this a teardown because I think there's so much rubbish coming out of China, some of which is just downright dangerous, that if you get pretty much anything that plugs into the mains from China, you'd actually be quite irresponsible not to take the cover off and just have a look at it to see if it's been made to a reasonable standard or not. But on this actually looks pretty decent. We've got a main socket there, heat shrink over there, main switch, double pole main switch with insulated connectors over here. The overall build quality, it's all through hole construction, which for something this size is pretty much to be expected. PCB, it's one of these fiberglass paper hybrid boards, which is the sort of quality you get on pretty much any sort of mid-range power supply. Quite decent, it's clearly been flow soldered, sort of good soldering quality, nice and accessible. The thing I like about this, and it's really quite important on anything like a power supply, is it's very easily repairable. There's no weird chips, it's all bog standard chips, LM358s, LM324s, all pretty bog standard stuff. So I mean, even the best power supply is prone to being blown up or getting killed by connecting something bad to the output terminals or something. So at least this thing, if it does die, it's pretty repairable without too much hassle. It's all the main board's very easy to get at. There's two minor little mods on here. There's that resistor there, but here this one is actually legended on the board, so that's sort of a semi-official mod. So a little diode in there. The overall construction looks pretty good. You've got plenty of input filtering on here. I think that's a power factor correction coil there. This link here, this is something you don't see very often nowadays, but it used to be quite common. This is for mains voltage selection. It's actually parked on this point which isn't actually connected to anything at all, but this gets connected over here for 110 volt operation, and that just configures these capacitors in a voltage doubler configuration. So that used to be quite common before the days when most switch mode power supplies were universal input. This is the actual range says it just says normally 240 volts, but again, for a bench power supply, universal voltage input isn't really a particularly big deal. For example, on this coil here, this is cable tied down to the board. The large bits are glued. I'm not really sure whether that glue is enough to really mechanically support it, but most of the big bits they have made an effort. The overall layout's sort of fairly neat. The back of the front panel, there's actually separate boards. There's like an output terminal board here. There's the board with the encoder on it here, and then there's a separate board with the meters and the display. And we've got noise filters on all the wiring to the front panel as well, so that's the ground wire from the front panel. So yeah, it's clearly a pretty decent quality of construction, and for this price range I think that's entirely acceptable. One issue to be aware of: this heatsink is live. Now, just looking at this, you might actually not think that, but if you just happen to look at it from this direction, there's this sort of neat little sticker that says, "Touching may hurt you by high voltage," but I think they could really have done with putting it on this face of the heatsink. But as long as you're aware of it, not a huge deal. If you look, the safety clearance on the board is reasonable. There's probably about 7 odd mil all round, which is perfectly acceptable. That heatsink it's maybe 8 to 10 mil from the side, so if you've got a really bad dent in the side, there might be some risk of shorting, but I think it is well grounded, so even if that did happen, it should blow the fuse. There's no separate fuse on the board because the fuse is in the back. I suppose there is a risk of idiot users putting the wrong fuse in there, but I mean that's always going to be a risk, so can't really criticise. And I think the overall architecture of this looks like we've got this power integration. This is one of these sort of all-in-one chips. And I think what's happening here is this is actually providing through this transformer here a DC supply to the secondary, which is actually operating all the control circuitry, and that's then providing the actual drive to the main switcher, probably through this transformer here. These capacitors are a little bit close to the heatsink. I'll do a test in a minute to see how hot this actually runs. There's a capacitor here next to a power resistor, but now normally that would raise sort of big warning flags, but this is actually the 0.1 ohm current sensing shunt, so the maximum power that's going to be dissipated in this is only 1 watt, so it's not going to get particularly hot. I think the reason they've used a big resistor is partly to make it reasonably rugged against transients, sort of sudden load surges, but also you don't really want your current sensing resistor getting hot because that's going to affect its accuracy. So that's, I think, that's perfectly okay. The output power connector that's actually been glued in, although it's a latching connector, they've put a bit of glue on it as well, just for good measure. But overall, I think that's as good as you could expect for this sort of price range. No real criticism of that at all. Right, this is the back of the front panel. We've got the meter board here. This has got a couple of microchip TC7129 digital voltmeter chips on there, fairly standard stuff. The encoder board, there's an 18 mega 48 there. And it looks like all this board is doing is taking these encoder inputs and producing, presumably via PWM, an analog voltage. So that's actually all it's doing. You've got the terminal board, there's a few capacitors to ground, which will be for noise suppression. One nice little touch on here is they've actually got separate sense. You've got these thick wires which are providing the power, and you've actually got these sense wires actually providing the reference voltage for it to control to, so any resistance on this wiring is balanced out. And one thing I quite like about this is it is a very simple modular design. They haven't crammed everything into a microcontroller. So, for example, I think that there'll be quite a lot of scope for hackability if you actually wanted to mess about with it. For example, if you wanted to say pimp this out with a nice colour TFT display, you could probably do that without too much difficulty. So if you want a nice customised power supply but don't want to get involved in all the actual power supply parts of it, you could potentially also maybe reprogram this to change the encode, maybe add some velocity sensing on the encoders. It's all sort of fairly modular and fairly easy to figure out how it all works, which I quite like. There's a couple of presets in here which I'm guessing these are the calibration for the meters, and these are actually the only adjustments. There's no other adjustments on the main board at all. This is the front of the display board. There's actually a few surface mount bits on the underside, although you'd never be able to get to them because the actual display is soldered through, so you'd actually have to unsolder the display if you wanted to do anything there. These wires just go to the backlight. It's quite a nice bright white backlight. Actually, what might be quite an interesting mod is to actually take that backlight strip off and replace it with RGB, so you can make the display change colour when the output was on or off. This is the front of the encoder board. Nothing exciting, just two encoders, a few caps, and that's the actual on-off push button. In-circuit programming header for the AVR there if you want to have a play with it. One little detail you need to be careful of, the encoder and display connectors are actually the same, so it is potentially possible to plug them into the wrong socket. So you need to be a little bit careful of that if you're pulling it apart. Right, while it was apart I was going to quickly experiment, see if I can increase the display update speed. Looking at the data sheet on this microchip DVM chip, there is actually quite a lot of scope for speeding up, so I'll just put this is a 22k resistor I've connected between pins 1 and 40 of the chip. I've just done one of them at the moment to compare the difference. Right, now this is the voltmeter I changed it, and now you can see it's much faster. The reaction time, this is much closer to what I'd consider acceptable for this sort of application. I did check, it does make a slight difference to the accuracy. At full scale it was reading about 100 millivolts low, but I just trimmed the pot on the board that's now back pretty much as close as it was before. It's within a few tens of millivolts over the whole range, so I think I'm going to do that to the other one. The display update, this is a nice crisp display. There's no issue at all with the LCD response time at this speed, even at extreme angles. I suppose there might conceivably if you're using this at very low temperatures, but other than that it's fine. I mean, this is a very nice display as LCDs go. I'm not, normally I'd expect a power supply to have LED displays, but this is easily fast enough to not really have any complaints compared to a LED display. It's nice big digits, big clear digits, wide viewing angle. It's totally fine. So the only criticism is the fact that the output on-off indicator isn't really as distinct as it could be. You can see the difference between the two. The current one's still running at the old speed, and that is just far too slow. So I think we'll stick that resistor on both of them before we stick it back together again. Well, I've got both meters sped up now. I don't think they're any jittery than they were before, but obviously the higher update rate makes them a little bit more, makes them look a little bit more twitchy. One thing that might be worth trying, actually, the microchip data sheet suggests that the RC oscillator can be a little bit jittery for they say it's okay for up to about 3.5 digit applications. It might be worth trying to add an external oscillator, because I put a scope on it and it did seem a little bit jittery, so it might be worth just trying to just add a more stable oscillator to that at some point, see if it makes any difference. One other thing I noticed, because this is using an encoder and presumably PWM, the setability seems to be basically about 10 millivolts. You sometimes find that you get two encoder clicks. You get one encoder click and no change, and the next one takes you 10 millivolts up. So that's slightly less nice than the multi-turn pot. But as far as I can see, I've not really probed around too much, but if it's the case that all that board is doing is providing these two reference voltages, it might be practical just to replace that entire board with a couple of multi-turn pots to give finer setability. So might have a look at that at some point. Right, I've got this nice big chunky 10 ohm 200 watt resistor. I'm going to leave it running for a while at full power, just see how warm it gets. Just while I've got this connected, I'll just crank it up to maximum, see what the maximum is. Yeah, it's going into a constant current at about 3.4 amps or so, but we'll just set the voltage to give it its maximum output current and leave it running for a while, I think. And just to confirm, it is the meters and not the actual output that's jittering up and down. This is the output voltage on my HP 34401, so the output voltage is certainly stable to within the measurement capability of those front panel meters, and I think maybe a more stable clock might actually give a much more stable display on those. One thing to be aware of is that in constant current mode there is quite substantial overshoot. What I've done is I've set the current to 1.6 amps, current limited, but the voltage quite a lot higher, and when you turn that on you do get quite a substantial current increase. That's not that uncommon on power supplies, and you know, this isn't a precision current source, it's a power supply with current limiting, so if you're using something that's sensitive, for example high power LEDs, the trick would be to actually, what I'm doing now is I'm just trimming the voltage down, so it seems to go to pretty much the maximum voltage and then go into current limiting mode. So if you're driving something that is susceptible to overcurrent, like say LEDs, you'd need to be a bit careful. You probably want to just turn it on, then increase the voltage slowly until it goes into limiting, rather than expecting it to go straight to the right current straight away. So if I sort of reduce the voltage, if I increase it, it should hit the limit. That's now, there's a little bit of a lump there when it goes to limit, but just something to bear in mind. I wouldn't say it's a particularly major issue, but it's just something you need to know about. Right, it's been running for about 50 odd minutes at full power, and it's feeling a bit warm. I would say that's definitely sort of warm rather than anywhere near hot. Let's measure the surface temperature, 35 degrees, 43 degrees at the output vents. Let's have a look at some of the internal temperatures. Right, these heat sinks, not too bad, although the being silver they might not be giving the right readings on this infrared thermometer. We've got about a 60 degree here around this transformer, 56, it's a 70, which I think is this big coil here, so look at the back. 50s, yeah, so pretty warm, but I mean not excessive, and you wouldn't often really run a bench supply at totally full blast for any serious amount of time, but it's a slight sort of warm smell about the thing, but then again it is fairly new, so I think that's pretty acceptable. Right, so to sum up then, good and bad points. Things I don't like, not showing the current set point, 4 mils instead of binding posts, a few minor issues with stability. It's only time will tell whether that's a really serious issue. Either there's only a few very narrow range of voltages that happens at. All in all though, I think it's pretty good value. If you pay less than about, say, 50-60 quid for a power supply like this, I think you're going to have to ask questions about safety, reliability and so on. If you want something that's super stable, super high quality, buy Agilent, TTI, whatever, spend 200 or 300 quid. But for a general purpose, everyday bench power supply, I don't really think there's any point in spending more than 100 quid on it, unless you've got particular requirements. If you need particularly high power, high precision, programmability or anything like that. But for just a general run-of-the-mill power supply, I think this is pretty reasonable. There's quite a lot of scope for the thing I like is it's eminently repairable. I'd sooner buy a cheap but easily repairable power supply than some really expensive piece of kit that's going to cost you a fortune if you do manage to blow it up. Quite a lot of scope for hackability. Okay, if you want to do lots of mods to it, you might as well spend a bit more on a higher end power supply. But if you're the sort of person that likes to customise your kit and do a few mods, this is eminently suitable because it's nicely modular. You could replace the metering, you could replace the encoder, you could do a few other little tweaks. The display speed up I would highly recommend doing, because the display is really too slow and it's just a couple of resistors across the chip. So yeah, that's something I'd recommend. I think overall, maybe 6, maybe 7 out of 10. If they'd done a few little improvements like a nice big on indicator, it would probably be 7, maybe 8 out of 10 in terms of value for money. So if you're looking for a reasonably priced, general purpose, well made, I mean the build quality is good for this price level. I've got absolutely no complaints whatsoever about build quality. I've seen far worse. And I've only seen better in power supplies costing twice as much. So yeah, I think pretty reasonable. I'd probably recommend it. There may well be better ones out there for the price. I've not really looked enough to know. I like the form factor. I like the fact that it's narrow. You stick it on your bench, not taking up too much bench space. You could stack like 2 or 3 of these side by side and still have a decent amount of space. So yeah, I think that's recommended within its price range, certainly.